Good afternoon, everyone, and welcome to the 2021 edition of the Prime Minister's Science Fair. I'm delighted today to be joined by the Prime Minister of Canada, the Right Honourable Justin Trudeau, that you can see on the screen, as well as Canada's Chief Science Advisor, our good friend Dr. Mona Nemer, and the President of the Natural Sciences and Engineering Research Council, what we call in our jargon NSERC, Alejandro Adem, in celebrating some of the best and brightest science students, that we are sharing the platform with today from across the country. And you are truly the star of what we're going to be doing today. And we're so grateful to be spending time with you today to hear about your story. And I want to say, chers amis, quelle belle.
And what a great initiative to get young people interested in science.
Watching today, or a teacher, or just even an enthusiast, we are delighted to support the great work of all scientists across our nation. If you think about it, science is at the center of our modern world. Whether it's exciting things like space travel, or something that you all know, the internet, or even artificial intelligence, all of that started with smart, tenacious researchers like the ones who are presenting today. And if you think about the big challenge of our time, whether it's COVID-19 or climate change, we know that the breakthrough are going to come from science, technology, and innovation. The breakthrough are going to come from you. That's why we're so excited to be hearing from you today. Comme le montre la pandémie.
As the COVID-19 pandemic shows, much of our health and safety depends in science. On
a changing economy, the job of the futures will absolutely depend on our next generation having the STEM skills and critical thinking abilities. We talked about that just before we went live, how much we need to build together the jobs of tomorrow. That's why our next speaker is so passionate about the subject. Ayant lui-même été enseignant, je sais.
As a former teacher himself, I know how important education and scientific research are important to the Prime Minister.
Rather than a classroom, he continues to be an advocate for youth developing scientific skills. So, dear friends, it's with great pleasure that I introduce to you the Prime Minister of Canada, the Right Honourable Justin Trudeau. Prime Minister, the floor is yours.
Merci, François Philippe. Thank you so much for your leadership as Minister of Science, Innovation and Industry. It is exciting to be here together for this virtual science fair. We've missed a lot because of COVID-19, but being able to gather with these three brilliant young researchers and find out a bit more about what kinds of projects they've been working on over the past few years is really, really exciting to me. Because we really need to be highlighting innovation and the strength of our youth. We can't do it, of course, without our own science advisor, Dr. Mona Nemer, and Alejandro Adem, professor who's in charge of this. Thank you, both of you, for being here, but mostly welcome Manning, Bhavya, and Isla. Looking forward to hearing from you about your different projects. One of the things that has really driven me as first as a teacher, then as an advocate, and now as a politician, is really looking to empower and invest in young people. We know that the way to build a better future is to make sure young people are able to contribute today to the future that we're building. And these investments and this support we're giving to young people in science is really, really important. I mean, we've been surrounded by this pandemic that has emphasized for everyone how important it is to innovate, to research, to push the boundaries of what we understand and how we respond to challenges. And young people have always been at the forefront of that. So being able to spend a little time with young people today and talk about their vision for the future is always a good day for me. Mais aussi le concept de la science qui est tellement important.
And there's also the notion of science that is so important to what we're doing as a government. For the past 5 years, we've invested in science and research because we know it's important not only for the future in general, but also for jobs and solutions for economic growth and well-being of citizens. And the COVID-19 pandemic is really showing that at the moment. So we want to celebrate science and young people and work together for a better future. So it's a good day for me.
Science fairs, I get to go around and visit a dozen or so different exhibitions and ask all sorts of questions. We only get 3 today, but they're the best 3. So I'm really looking forward to it. And with that, happy to pass it back.
Well, thank you very much, Prime Minister. Monsieur le Premier ministre, merci beaucoup. Pour moi, c'est une...
Thank you, Prime Minister. It's a very special occasion because I'm here with you and young people. And that reminds me that 3.5 years ago, time flies, that I was appointed as Chief Science Advisor. And you know, we've been very busy during the pandemic, as you said.
Sincere commitment to science, to youth, to research. It's such a pleasure to work with you, and Minister Champagne, it's really great to be with you and see all the great work that you're doing for our country in terms of science innovation. Alejandro, dear colleague, always a pleasure to be here. But above all, it's we're here because of these young, extraordinary scientists, researchers, who are really, you know, the hope of Canada for tomorrow. And I'm just so delighted to be able to introduce them to you, Prime Minister. So we'll just get started rapidly. The first presenter is going to be Manning Whitby. And Manning is the winner of the Best Senior Project Award at the 2019 Canada-wide Science Fair. While in high school, Manning worked closely with low vision communities in Toronto and Ottawa to investigate the design of wearable technology that could give users greater spatial perception. This led him to develop the innovative device that he's presenting to us today. After excelling at the regional and national science fair in the senior year, Manning went on to represent Canada at the European Union Contest for Young Scientists in 2019 and won a special award. With 500,000 blind or partially sighted people in Canada and hundreds of millions around the world, his innovation has the potential to change many lives. Manning is formerly a competitive swimmer, and he just told us that he's been cycling a lot during the pandemic. He does enjoy biking, enjoys adventurous science fiction as well. Manning, welcome, and please tell us all about your project.
Hi there. Afternoon, everybody. Thank you for having me today. So yeah, the research I conducted in my senior high school year focused on addressing challenges faced by blind and low vision communities, specifically using traditional tools such as the white cane and guide dog. The white cane is the most commonly used mobility tool today. Actually, this year marks its 100th anniversary. Its design is simple, its operation is intuitive. However, it provides very limited spatial information. The user knows only as much as a cane sweep can cover, and that's the immediate environment. The second most common mobility tool is the guide dog. In many respects, they are far more superior to the cane. As the task of obstacle avoidance is delegated to our furry friend, users are focused less with the immediate environment. The downside, though, is dogs are a lot of maintenance. They require the same basic attention, care, play, and food as dogs that don't work. This costs time and money that not all individuals are able to support physically or financially. I explored the research now explored how to design technology that would improve users' spatial perception while providing a seamless and intuitive experience. I explored the design of a sensory substitution device, which I investigated how to collect the rich spatial information and how to communicate it. So in designing the collection system, I considered the characteristics the user needed. The user needed to receive information in real time. They needed to work both indoors and outdoors and collect or detect obstacles of varying heights and positions. It needed to perform in day and night conditions, have a range greater than the white cane, and detect both dynamic and static obstacles. The technologies that I found to best meet this criteria were ultrasonic and LiDAR, right in the middle. Both these technologies measure distance. However, ultrasonic uses sound and LiDAR uses light. A rudimentary prototype, let me find it. So this one. This was one of the first ones. A rudimentary prototype was outfitted with an arrangement of these sensors, and they were all symmetrical because it was initially hypothesized that all locations around the user were equally important. However, through testing, it was determined that the most effective areas to measure were at or below shoulder level. So this led to the design of the second prototype. You can see it's a bit stripped because of I've had to scrap it for some of the parts that I've used in the newer model. And so as a directive was in designing a sensory substitution device, I reviewed all the sensors that could replace sight or substitute sight and communicate spatial information. And it might seem obvious that sound and touch would be the most effective, but I wanted to be thorough. And so I explored devices that artificially produce smell or operated on the tongue. But after interviewing various individuals, I began to understand more about blindness. Although blind people may not physically have better hearing, as people might think, they certainly use it much more. So communicating through touch was determined to be the most effective, as it would not overlay information on this important sense. This turned out to be the best choice regardless, because the large surface area of the skin made it possible to communicate unique pieces of information at various locations. I now needed to investigate where exactly on the body to communicate this information and how to communicate this information. The criteria were that users be able to discern the complex input and respond quickly to the cues. So with the support from the blind community, I performed tests using vibrotactile stimuli on the legs, forearms, biceps, triceps, shoulder, chest, and abdomen region. And in the tests, I found that the arms, so the forearms, biceps, and triceps, were the best locations. I then performed a study to understand the response to stimuli differentiation. This was the how. I was essentially trying to understand the resolution of image I could define on the arms. The closer the vibration motors, the higher the resolution, the closer the vibration motors, and the more challenging it was for users to differentiate the input. It was also determined that if the input changed continuously, as opposed to in steps, it was significantly more challenging for users to understand the change continuous. So my final experiment was to investigate what was the most differentiable difference between these steps. So now that I completed all these sub-studies, exploring the different questions of the systems that compose the device, I paired them together by development of another prototype. So this was the final prototype. You can see that it's slipping a bit because I've actually lost the front strap. It usually wraps around the neck like a pendant, and this usually clips in on the side. So in simple terms, the operation is similar to like an advanced backup camera. The closer the users approach an obstacle, the more intense the vibrations are. Not only did it provide users with information about the depth, but also the location of obstacles vibrating in the direction of these obstacles. And learning this system, this rudimentary system, was challenging for users, but in controlled mobility experiments, users displayed improved confidence in direction and efficiency. And the final prototype collected more spatial information than the white cane, and the increased range paired with this novel communication system allowed them to predict their environment and make stronger decisions. Thank you.
Well, thank you so much. This is amazing, this intersection of neuroscience and physics and technology. It's fantastic. Prime Minister, I believe that you have some questions, perhaps.
Thank you, Mona. I have so many questions for Manning, and you answered a lot of them. I was curious because in what I'd seen, I wasn't sure whether it was ultrasonic or lidar, for example. So it's neat that you have a difference. Why is the lidar in the center and the ultrasonic on the side? Does that make a difference, or would you have been all one or all the other? What was the configuration that was important? And then the second question, how long does it take, because you talked about it a little bit, how long does it take someone to understand the information they're given, to make a mental map based on this very clear but obviously not intuitive way of perceiving, okay, there's a gap, that means a door over that way is, my biceps is buzzing on this part of everything. Like, how long does it take for people to get good on it? Is it a few days? Is it a few hours? Tell me about this.
Yeah. So the two technologies, ultrasonic and LiDAR, ultrasonic is very affordable. It's readily accessible, but LiDAR, as we see on most self-driving cars today, is a much more expensive technology, and that's because it uses light. And so a whole system using LiDAR would not be affordable. So the reason why I positioned them, I have them pointing that way, and one right at the bottom pointing directly down. And the benefit of pointing directly out is it provides the macro perspective of the environment. So the LiDAR has a 40-meter range as opposed to the ultrasonic, which only have a 4-meter range. And so the distance allowed them to understand the true depth of whatever environment they were in. And then it pointing down, well, I wanted the benefit of having it respond in real time, because light is immediate. So this points down and it lets them know, are there any drop-offs? What are the stairs like? It was more of a safety and necessity. In terms of learning the device, so throughout the study, trying to practice with users, you had to introduce this new language to them. You wouldn't give them all the information that you have accessible to them. Like, you wouldn't give them like a 4K image and say, go try and explore the world. So it was not only were we designing the technology, but we were trying to understand the onboarding process and how to make it efficient for them to consume. So we did varying tests. Some were weeks. We unfortunately we didn't get into like a year-long longitudinal study, but I think the most I had worked with was 3 weeks, and this was just starting on simple basic courses and then training individuals through weeks to get them to understand the different cues, and then slowly build up their language base. You know, like me learning French, and we start with conjugatives and then we slowly build to a conversation, and that's the same principle.
And has over the past year or so, has it been taken on commercially? Are there further studies going on? Has it taken a life of its own as you move on to other projects, or is it still just an interesting idea out there?
Yeah. So this May will actually mark 2 years since this research was presented at the Canada-wide Science Fair, and yeah, a lot has happened in the 2 years. So right after the fair, I had to jump back into school mode and sort of finish that up. But I definitely knew I wanted to take this idea further. So I applied and got accepted to the DMZ Basecamp program, which is a pre-accelerator hosted by Ryerson University. And it takes idea to creation. And then while in this program, I began to considering who I might want to partner with and propel this idea further. Oh, sorry, I'm looking at my laptop here, and my camera's here. Yeah, so, what's amazing about these science fairs is it's wildly unique people you meet with their own skill sets. So coming from the science fair, I knew these two friends, Lucas Krupi and Ethan Bray. I wanted them to join me because I had spent so much time with them at the fair and got to know the extent of their research. So after the program at DMZ, I moved to Ottawa for only 2 weeks, and then I flew out to Bulgaria with Bavia for the European Science Fair. We then formalized our team, and we incorporated under Inconav Technologies Inc. in November. Then we expanded our relationships with CNIB and the Canadian Council for the Blind and all these major foundations to help propel us and reach out to the Ottawa community. And then we did various pitch competitions. So we won at the U Ottawa Elevator Pitch Competition. We did the Entrepreneur Concept Competition. We actually applied and got accepted and moved on to the semifinal round of the Bangkok Business Challenge, which is the longest running Asian business competition. But this was right around the time that the coronavirus was spreading. And I think at the time there were only 14 cases in Thailand, which it was a bit unfortunate because the organizers had planned some cultural events that I was looking forward to. But yeah, as it progressed, everything moved online. But so
well, you have life ahead of you. Not to worry. I think that Minister Champagne may have an offer or a question at least for you.
Manning, I'm happy almost you didn't go, so we didn't have to repatriate you, because I would have to find you. The Prime Minister would certainly ask me, where's Manning? And I would have to find you somewhere on the cultural side in Thailand. So yeah, you did well to
that was a big fear, but yeah, they moved it online. But then as the pandemic started to develop, we just sort of collected our thoughts and sat down, and this was months after we incorporated, and we sort of realized that we had been crawling upstream for these months and making no real improvement, because, you know, in the startup world, your iterations need to be fast. You only need to be concerned with the core technology before expanding and working on these different ideas. And this is where the disparity between conducting a research and developing an innovative project became apparent. You know, as researchers, we try to explore questions that have yet to be answered. When I first started working on this idea, the questions I had was, why hasn't modern technology come to this population, and what sort of technology can be developed for them? But, you know, researchers are not always thinking, how can this be a viable product in the marketplace, and what, you know, financial viability is in this solution? And so when I attended this business accelerator and learned about all these principles, I was confident that I already knew the target audience and that the core technology was addressing their challenges. And so the work that Ethan and Lucas and I focused on, it just tried to advance what had already been researched, instead of actually going back and verifying more and more with the target audience, is this a product? And so the challenge we later understood was that, and why technology in this population has been so stagnant, is that the barriers to enter this market are relatively high. As you did mention, it's 500,000 in Canada and a couple million in the North Americas. But when you consider that compared to other markets, on top of 70% of the population being unemployed, you know, it made it even more challenging. And developing a hardware technology which costs significantly more research dollars as opposed to software innovations made the direction even more challenging. And I took the traction I gained from the research and took it as a product, but they're completely different things. People who showed interest in the research wanted these questions answered themselves. They were curious about the technological potential. But what I wasn't asking in the research was, would you buy this prototype? Would you spend money on this rudimentary concept today? Is it worth your money, and how much would you pay? And this is like a rule all startups should follow. As a business, you know, you want to be financially sustainable. And if you don't have financial interest from your audience, it should be back to the drawing boards. But we weren't asking these questions early on. Instead, we worked on features that the core product didn't necessarily need, like replacing these proximity sensors with depth cameras and adding all these features that weren't necessary to the core product. And so adding on these core features, just, we were working on things that we didn't quite have the experience to work on. And, you know, we were working on the same iteration since incorporating in November all the way to like spring or summer. We were working on the same one. So, and then we began asking these questions, and we got positive interest, but the interest in what people were willing to pay wasn't as much as what the project would have been to be sustainable. But so at the beginning, we were very naive in a business perspective, but as our entrepreneurial minds matured in the later months, we learned significantly more. But after we sat down at the beginning of COVID, we realized that this was just, we had been traveling upstream, and we sort of ended it there. But I'm still really close friends with Lucas and Ethan. You know, we talk almost every day, and we talk about reviving IncoNav in a multiple of forms. So I'm excited about that.
Well, that's great. That sounds like you're very excited.
Thank you.
Minister Champagne, did you have any?
Well, I just want to say, Manning, would you accept to come talk to my whole department? We have some sessions, and I'd like them to hear from you because you explained from the Eureka idea you had to commercialization. I like the way you put it and the energy you put in it. And maybe offline, we can talk about version 2.0 of your product. Because I do know we need to move on, but you know, you have a standing invitation to come to talk to the 5,000 people in the department so they can hear directly from you, and so inspire us and continue to do that. So
I would love that.
But you have a standing invitation, sir.
Thank you. Yeah, put a bit of fire under their belly and show them that the youngins are going to come and take the jobs from them.
I love that. That's the spirit.
I want to be a bird in the room.
Yes.
Okay, this is very great way to start. So our next presenter is no less interesting and actually extremely relevant. So it's Ayla Graham. and Ayla's work is on environment in the area of environmental sustainability, and something that Prime Minister, you care a lot about, which is the zero plastic in the environment. So Ayla is the winner of the Best Junior Project Award at the 2019 Canada-wide Science Fair. She's participated in science fairs for 6 years and has a passion for environmental issues. In 2018, her project, which studied microfibers and how to filter laundry water, won Blue Water Junior Best of Fair. As we know, minimizing microplastics is part of Canada's zero plastic strategy. So this is certainly a very important research and a very bright future for you, Ayla. Ayla's 2019 project, Rake Rack Risk, studied the endangered Great Lakes piping plover that nest at Sauble Beach. Her project won Best of Fair at the Blue Water Regional Series Science Fair. She's also won a Youth Can Innovative Award and a scholarship to Western University, and was chosen to represent Canada at the 2020 Broadcom Masters in Anaheim, California. She enjoys volleyball, art, and playing piano. She also volunteers, and in 2020 received the Ontario Junior Citizen of the Year Award. So over to you, Ayla, and I'm already feeling like totally underaccomplished.
Well, thank you. Good afternoon, Mr. Trudeau, Monsieur Champagne, Dr. Niemer, and other members of NSERCS. My project was entitled Rake Rack Risk, about the Great Lakes piping plovers. This is a photo of them, and this is the adult plover, and this is the chick. They have been endangered since 1986, and in 2007, they returned to Sauble Beach, Ontario. In 2019, there were only 8 breeding pairs remaining in all of the Canadian Great Lakes. The town of South Bruce Peninsula has performed beach maintenance using heavy equipment such as bulldozers and hi-hos. This is a before and after picture of what the beach maintenance has done. At the top, you can see there's lots of vegetation and debris, and in the bottom, there's no slope remaining in the beach and no vegetation or debris as well. The mayor believes that the plovers prefer a clean beach, and that the clean beach is a good attraction for the tourists. And this led me to the purpose of my investigation, which was to determine whether the Great Lakes piping plovers prefer a clean beach. I hypothesized that the rack line would be particularly important. The rack line is the high watermark of the beach, and it contains stuff like driftwood, reeds, sticks, stones, and shells. And it also provides the plovers with camouflage, food source, and shelter. I conducted 3 different studies, and my first was a historical study of nest sites. I looked at 28 different nest sites of plovers over the past 15 years, and amounts of vegetation and debris in each of the nest sites. And I was looking to see whether vegetation and debris is found in their ideal habitat. My second study was a comparison between the 3 nests in 2018 at Sauble Beach. And I was doing something similar to my first study, but looking more at the exact counts, because I was able to go inside the plover exclosure once the season for plovers was over and they had migrated already. I was able to get a closer look and identify the different sorts of vegetation and debris that were inside. And my final study was a behavioral study, and this I conducted over a 4-week period with 43 separate observations. I collected 609 behaviors by the end of my study, and I was basically recording the different behaviors and where the behaviors were seen of the plovers and where they spent most of their time. In my observations of my first study, this is a graph you should have as well, and I showed in green the percentage of vegetation in a nest, yellow represents the wood and reed coverage, and blue represents the stone and shell coverage. And overall in this graph, it showed that none of the nests contained no debris or vegetation, so they all contained some sort of it. And overall, I averaged this and found that an ideal plover habitat should contain 10.9% of vegetation 12.7% of wood and reeds, and 17% of stones and shells. So an ideal plover habitat in Ontario should contain about 40.9% of coverage with vegetation and debris. In my second study with a comparison of the 3 nests, it was again very similar, but here are the 3 nests from 2018. Nest 1 contained the most amount of wood and reeds, Nest 2 contained the most amount of vegetation, and Nest 3 contained the most amount of stones and shells. And again, all of them contain some sort of vegetation and debris, and this was sort of a backup to emphasize how much it was important for their ideal habitat. And in my final study, again, I had collected 609 behaviors of the plovers. And out of the 609, in this graph, it represents that the rack line, they were seen there 343 times. And the most common behaviors were sitting, feeding, and standing. And the rack line was a safe place for them. There was lots of human disturbance over the summer. And so when a person would walk by or something and they were down at the shoreline eating, they would retreat back to the rack line because it was like their safe place where they could camouflage and go back to for that. And then also they were seen there feeding quite a lot. And it was just somewhere where they spent more than 56.3% of their time. And my conclusions found that the Great Lakes piping plovers do not prefer a clean beach. They make use of many parts of their habitat, but the rack line was particularly important because, as I hypothesized, it provided them with all of the things that they needed. And as well, the beach maintenance and raking does affect their habitat because in all 3 of my studies, it showed that they require the sort of vegetation and debris for them to have an easy lifestyle and to continue their existence. And so I concluded that the, raking the rack line before the plovers arrive could potentially be damaging to them and hasten their extinction. Thank you. Are there any questions?
Thank you so much, Prime Minister.
Thank you, Mona. Thank you so much, Isla, for your work. It sounds like you were out there observing plovers quite a bit. One of the interesting things to me is, did you find out what sort of the assumption that the town made that plovers prefer a clean beach? Did they base that on anything, or was that just conveniently aligned with, well, humans prefer tourists prefer a clean beach? Did they have any justification that you found, or was that just an assumption they made?
I think it was more of an assumption, to be honest, like led to the tourists' preference and whatever. But there's also like the Ministry of Natural Resources. They had also like come in and like tried to explain like more about that as well. And it was a court case and everything too with that. But no,
so
I think
the Ministry of Natural Resources was saying that yes, they prefer a clean beach, or was they saying no, they need debris?
They needed like that kind of stuff, and that the beach maintenance was affecting it.
It makes a lot of sense, but you have less life in a desert, and that after picture, I mean, it's sort of obvious. What in the time since has there been attempts at a compromise? Because you're not going to get a lot of tourists in the basically the grassy beach, but knowing that the rack line is particularly important and a little bit of vegetation, has the community adjusted its approach a little bit? Is there an attempt at a balance and a compromise? What have you found?
Slightly, but because of COVID and everything, it's kind of everything's been shut down like several times at Sauble. So it was definitely minimalized, the amount of population that was like down there during the summer. But as well, there's like a volunteer group called the Plover Lovers, and they have helped educate the public and they help give more awareness. And I think this could be more emphasized more towards tourists and make plovers more of like an attraction because they're an endangered species. So it's kind of cool to be in the same place as one. And as well, I think that they also help a lot because we put boundaries around their nest sites, like 2 boundaries, one for the exclosure for predators when they first nest with their eggs. And then again, we put a larger one and lots of signs to help human disturbance not affect them as much.
Excellent. And when you talk about these plover lovers, I assume that they have been greatly helped by the research you've done. So it's a great example of doing the work. Over 40 observations over 4 weeks that you've had to do actually shows how better understanding the environment is key to making the right changes.
Okay. Minister Champagne, do you have a question?
Well, I would have many, to be honest, but I would just say we need more people like you in Canada. I would say even in the world. I mean, what I was listening to you and I was saying, maybe more on the personal side, what inspired you and who inspired you to take on that project? What was the spark that you said, I need to do something? Because many of us see things, but very few of us would act on something. But definitely you saw something and you said, that's not right. Let me study it and study it thoroughly and then come back with some form of recommendation, as the Prime Minister said. What was the moment you had and you said, enough is enough, I'm going to do something, and who inspired you?
Well, I've always had like a big inspiration towards environmental issues and whatever, and trying to help assist with that. But more it was the fact that they said it didn't affect their habitat. And I was thinking it's an endangered species, and those are the most at risk at this time. And so it's important that we pay attention to what they need, so then we can keep them for as long as possible and help their species as well. And so I just thought that, if you have proof and whatever, it's it's really good to bring that up to them, because one species leaves and then they're all going to be gone soon enough. So you have to start soon enough. And yeah.
And is there anyone who inspired you, or you just took it on yourself?
I had joined the Plover Lovers first, and meeting and making all those connections there. And I had done some studies with Trent University before as well, with insects and invertebrates that they ate on the shoreline. And that was really cool. So I was just really interested and passionate about studying more about these birds and helping them as much as possible.
Okay, well, you have a standing invitation again to come talk to my team about inspiration and the drive, because we see a lot of things, but few of us act. I think we're all very proud of you to take on that. And what's your next big project, if I may? If it's already confidential, I don't want to break the news now.
No, I've been working on one using thermoelectric generator tiles. And so basically one side, they make voltage and energy produced by the temperature differential between the two sides of them. And so I created a prototype after doing all of my experiments before. And the prototype basically is to collect waste heat and then turn that into a usable form of energy. And so it could potentially be used later in the future against climate change, and put all of that all of that waste heat into something that we can use.
Wow. Looking forward to that, sir.
The future's in good hands, François.
Absolutely. And actually, our health is also in good hands with the next presenter, Bhavya Mohan, who is the winner of the best project at the 2019 Canada-wide Science Fair for his work in aptamer-based bite research. Over the past 7 years, Bhavya has conducted research in the fields of nanotechnology, disease diagnostics, and cancer immunotherapy. More recently, he's focused his research on improving a popular immunotherapy called BITE that he will talk to us about using aptamers. His work has shown promising results in the lab and has been awarded a Youth Can Innovate Award. He was selected to represent Canada at the International Science and Engineering Fair and the European Union Contest for Young Scientists. Outside of research, Bhavya enjoys playing pickup basketball. He volunteers for local charities, and he provides mentorship to youth across Canada to help them develop their own science projects. I think you're going to get an invitation from Minister Champagne too. So Bhavya, welcome, and tell us all about BITE and A-BITE.
Well, hello, Mr. Prime Minister, Minister Champagne, and everyone at NSERC. To start, thank you all so much for having me at this event. As was said, for the last 3 years, I've been conducting cancer immunology research in Dr. William Wilmer's lab at Carleton University, where I've specifically been working on improving a popular immunotherapy called BiTEs. However, before I dive deep into the details of my project, I wanted to provide a little bit of an insight into my research journey. So I've actually been conducting research ever since I've been in grade 5, when I initially learned about cancer at a school event. I remember I'd gotten home, was curious, and explored the disease online. I was fortunate enough to have an older brother who is 6 years older than me, and he provided me his biology textbook and truly helped me learn as much as I could about cancer. So after initially deciphering all the complicated jargon, which is in scientific literature, I slowly was able to develop a few ideas on how to improve current immunotherapies and actually treatments. And then ever since then, I've worked in Dr. William Wilmer's lab, where I've been evaluating my ideas and have been growing and learning through the process. So this initial research exposure for me was very beneficial and was of pivotal importance in helping me develop my current cancer immunology project. In grade 10, I had met a patient who was actually undergoing an immunotherapy called BiTEs. Now, BiTEs stands for bispecific T-cell engagers, and these are these large protein complexes, so they have, which connect two separate antibodies. So one of the antibodies is specific to a T-cell, and another one is specific to a cancer cell. And as such, what BiTEs are able to do is they're able to force these T-cells to come and recognize and kill the cancer cells. So the BiTEs have the potential to be very effective. However, they have a few limitations which make them not as effective as they could be. To start, they're really large structures, and as such, they're only able to target the surface of the tumor and not the entire tumor. Second, and probably the most important, BiTEs can actually cause an adverse immune response because they're protein-based. So instead of the immune system targeting the cancer, sometimes cases can occur where the immune system recognizes these BiTEs as foreign and then starts targeting the treatment itself. And then finally, they're really expensive to produce. So having looked at all of these concerns, I connected it with my previous research in which I'd used a technology called aptamers. Aptamers are these single strands of DNA. So being single-stranded, they're able to form these unique, they're able to fold into these unique shapes and are actually able to bind to proteins just like antibodies. So, and in comparison to antibodies, aptamers are actually less immunogenic. They're significantly cheaper to produce and can actually reach the center of the tumor where they could be the most effective. So having looked at all of this, I began to wonder if aptamers could actually serve as a better alternative to these traditional BiTEs. So that's how I came up with a project to create an aptamer-based BiTE, or as I've called them, ABiTEs. And I've been working on this project for the last 3 years now. So over the course of my project, I've grown cancer cells and immune cells in the laboratory, have performed several tests such as surface plasmon resonance, flow cytometry, as well as fluorescent microscopy. And through my research, I've actually been able to show that my aptamer-based BiTEs, these ABiTEs, are 1.6 times more effective than the traditional gold standard BiTEs which exist in the market today in the laboratory setting. Of course, this is promising results, but further testing is needed to actually evaluate the true effectiveness of these treatments. So going forward, I hope to continue improving my research, conducting more experiments, and truly making ABiTEs as effective as they could be.
Thank you so much for this very clear presentation. Prime Minister, you've heard a lot about antibodies and T cells. I'm sure you have some questions.
Yeah, for sure. Help me understand a little bit more, Bhavya, about aptamers. Like, what exactly is aptamer, and how is that a better vehicle? I know you touched on it briefly, but that seems to be the innovation that is potentially unlocking much more efficient treatments in the future.
So to talk about aptamers, I guess first you get to, I can sort of demonstrate what the shape of an aptamer is. If you can imagine DNA, which is diribonucleic acid, it's double helix, so it has, it intercoils within itself. So an aptamer, in essence, is just a single strand of this DNA. So being single-stranded, what an aptamer is actually able to do is its nucleotides can fold onto one another and form these unique and complicated shapes. And as such, what aptamers are able to do is they're able to bind to these proteins just like traditional antibodies. So aptamers are a technology which is commonly used in disease diagnostics. So that's where I was previously using them. However, in this new context, I'm trying to use these aptamers to cause immune responses against cancer.
And so aptamers are not proteins themselves?
No, they're nucleic acid based, yeah.
Okay, and are you having to change the BITE technology significant to adapt to the aptamer, or is it just sort of an additional step?
So with the BITE, the shape of the BITE, they have one which is specific to a T cell biomarker and one which is specific to a cancer cell biomarker. So research has been done to create these BITEs which are protein complexes. However, in my case, when creating these A BITEs, I similarly had to take a aptamer, which is an aptamer specific to a cancer biomarker, an aptamer specific to a T cell biomarker, and then combine those. So in the process of combining them, the shapes of these aptamers don't necessarily align perfectly, as you could imagine. So there was a lot of testing and computational work that had to go in to sort of predict what the structures of these A BITEs would be. And to the best of my ability, I had to modify these structures as much as I could just to make them the correct shape or the desired shape that I wanted.
I love that you're talking about you had to modify it, you had to create the corruption. These are all things that you can't even see with the microscope, right? I mean, you're almost using mathematical models to try and imagine how they're doing and what they're connecting, and you observe the results to say, oh, that one worked, it must have the right shape, and then you sort of go from there. Just amazing what you're doing. I'm very, very excited about the job François-Philippe's about to offer you.
Thanks.
I would listen to you all day, you know, honestly, I'm taking notes as you speak, you know, because it's phenomenal. I mean, you said you had your brother, and, you know, seems you must have a family who loves science, I must say, to be where you are now. But how was I have kind of a question. How do you feel supported in the ecosystem? Because you have access to labs. I mean, you're fairly young, you're doing things that I would say, I'd like to put you in touch, but we have Dr. Mona Nimmer with us, so we'll put you in touch with the right people. But I'm just saying, how did you feel in the ecosystem? Did you feel supported? Do you feel there's gaps? Do you feel that a prime minister and I could say, listen, if we wanted to help you and others, to say what has gone right and what could we improve in order to come to the next breakthrough that you're doing, and probably friends that you're working with, I assume, in these labs?
I think definitely I've felt supported throughout my journey. I've definitely gotten very fortunate to meet people like Dr. Wilmore, who has accepted me into his lab when I was in grade 5, where you could imagine I didn't know much about biology. So I've had individuals who've truly supported me throughout my journey and who've made it possible for me to conduct the research that I've been able to do. But I think I've also met individuals across Canada who too are conducting meaningful and truly impactful research. So I think throughout Canada, there is a great importance on youth research. And I find each year there's an increasing number of individuals who've been able to conduct laboratory research and work with professors. So I do believe that there is a great ecosystem in place.
Well, thank you so much. I think that we've had, an amazing demonstration of the incredible richness of this country. It's the wealth of the young people, but also those who have helped them, as Minister Champagne, you've noted, they went in labs and they were supported. And this is also what our research enterprise does, is develop this talent and all these skills. And I don't know about you, but I was just like fascinated how natural multidisciplinarity came to these young people. I think they're definitely a great inspiration. And Prime Minister, thank you so much for hosting this science fair and your continued support. I was afraid what answer when Minister Champagne asked what can we do more, because I know if we had older researchers what they would say, but these young researchers are amazingly sort of down to earth and very pragmatic and respectful. So thank you for having me with you, and I think now I will turn it back to the president of NSERC, Alejandro Adam, for the rest of the event.
Thank you very much, Dr. Nemmer. So I'm the boring math professor, and you guys have just blown me away, I'm so happy to see that even as we still grapple with the challenges of the global pandemic, the future of discovery and innovation in Canada is very bright indeed. To our young guests of honor today, thank you for your wonderful presentations, et félicitations pour vos projets gagnants. What we see in your projects is research, science, but also innovation and the desire to do something for society. So those are important ingredients of what it is to be a researcher, a scientist, and engineer. You may not be familiar with NSERC yet, but our vision is to help scientists and engineers, like each of you, because I see one in each of you, to find a path to a future that includes science in a meaningful way. And that doesn't mean being a professor. It can mean having a startup, helping society, doing all sorts of different things, even working in government. We provide scholarships to students in high school and CEGEPs. We fund science-themed groups and events in your communities. And once you enter college or university, we provide grants to support your training while you work on research projects. In particular, I draw your attention to the USRA Undergraduate Student Research Awards, which are a great source of inspiration for budding young scientists at universities. But NSERC is much more than a source of funds for grants and scholarships. We also strive to be a leading voice in creating a stronger and more inclusive research culture. Nous collaborons avec de nombreux partenaires.
We collaborate with many partners, researchers, and youth, promising youth like you, who are passionate for research and engineering. Thank you very much for helping us achieve those goals together.
For once again hosting this celebration of Canada's outstanding young researchers and innovators. A scientifically literate society is better positioned to confront far-reaching problems like those that we face every day now. And I appreciate Prime Minister Trudeau's commitment to encouraging all Canadians of every age to celebrate and embrace science. I would also like to thank Dr. Nemmer and Minister Champagne for their guidance and fantastic support. L'année écoulée nous a montré.
The past year has shown us how science and engineering are essential to Canada's society and for the future of our country.
The future achievements of today's young presenters as they continue to use their talent and ideas to solve the world's challenges and improve the lives of others. Because after all, that's what it's all about. And I'll now turn things back to our Prime Minister for some final thoughts.
Merci beaucoup, Professeur Adem.
Thank you kindly, Professor, for your leadership and for hosting us here.
To be able to meet Manning, Ayla, and Bhavya, and see the work that you've done and hear about the work that you're going to be continuing to do. I want to take a moment, though, and not just to thank everyone on the call, but I want to thank the parents, the coaches, the teachers, the mentors behind each and every one of you, the friends of the Plovers, the folks who the Plover lovers, sorry, the people who've your older brothers, the people who've been continuing to pull and push you along, inspire you, and give you the resources and the ability to contribute in so many really concrete ways. We need young people like you to continue to challenge, to push, to imagine a different and better world. And I'm just so excited about everything you're doing and about the future that we are all going to be building together. Alors, merci beaucoup, mes chers amis.
So thank you to all of you, my friends.
That you've done so far, and I can't wait to see what you're going to do next. Merci beaucoup tout le monde.
Thank you all.
Thank you.
Thank you.